Okay, good morning all. Today we are gathered here to discuss about the design thinking approach, which is based on full adder. The full adder, which is one of the type of combination circuits. The combination circuit is nothing but it will be provide the output with the help of only input, and there is no feedback related to this circuit. The combination circuits, there will be three categories mainly. First will be it is doing the arithmetic and logical operations, and second one will be using for data transmission, and third type will be used for code converter. And the first type we are going to discuss about the arithmetic and logical operations. In that we are having the adder circuit and subtractor circuit is there. And coming to data transmission part, there will be having multiplexer type and demultiplexer type, as we can discuss that later. And third one will be code converters. There will be a gray to binary code converters, and there will be a magnitude comparator and current segment converters will be there. Today, the design thinking at FNS institution, we are following the design thinking approach. It is basically 5 stages. First one will be the empathy part, and second one define part, ideate, prototype, and test part. In arithmetic and logical operation, today we are going to discuss about only the full adder. In each stages, we can elaborate the full adder circuit. The full adder, which is basically is having a 3 input and it will be having 2 outputs will be there. The adder, which is commonly having the output of sum and carry will be there. Students, let have some discussion related to the topic, and each individual stages we can elaborate the presentation. Let's start the discussion.
The empathy part means deeply understanding the user's perspective, frustrations and limitations when an essential component is replaced with a less capable alternative. When we use a half-adder circuit, we can only add two single bits, and we cannot process the carrying previous addition operation. Thus makes multiple addition more complex and error-prone. Users or design students may feel forced to cascade multiple half-adders and do extra logic with the hands when a full adder automatically does the operation. It actually wastes time and increases the risk of mistakes. And users or designers may feel overwhelmed when a simple concept like binary addition becomes more complex when it comes to practice and resulting in disengagement or even discouraging the further study. A, B, C, I, N and produces sum and carry. Full adder should be accurate, efficient and minimize propagation delay and for practical implementation. Design a full adder that prevents binary addition with minimal delay and resource usage. This step ensures you know what needs solving before moving to idea generation. Now I am going to discuss about the ideate part of the full adder. At this stage, the goal is to explore multiple ways of realizing the full adder circuit. The first possible approaches, the first one is gate level design. Use basic logic gates, AND gate, OR gate or XOR gate to build the circuit. Emphasize clarity for beginners by using color-coded connections or annotated diagrams. Next one is half-adder combination. Connects full adder by using 2 half-adder and 1 OR gates. Next one is multiplexer. Use 4:1 multiplexer to design a full adder more compactly. Suitable for application requiring more components or optimized. optimize the transistor level implementation to reduce power consumption and propagation delay.
Here we are going to discuss about prototype of full adder. Definition: a full adder is a combinational circuit that adds three binary inputs A, B and C in. Working principle of the full adder: sum is obtained using XOR gates of the operations of the three inputs, and carry is generated when at least two inputs are 1. Prototype implementation: using the logic gates XOR, OR and AND gates, or using two half adders plus OR gates. Output: sum which is equal to A XOR B XOR C in, and carry which is equal to A dot B plus C dot A XOR and B. Applications: it is used in digital systems for binary addition and using building block of multi-bit adders.
Now we are moving on to the testing step of the full adder, and firstly basically testing step on the full adder is mainly based on the usability, performance and educational values. And whereas in this usability, that is easy to use, and testing should not feel complex for anyone, and learnability and accessibility, these are the things under the usability. And performance, like speed of testing, and hardware with the ICs, and accuracy and reliability, and next scalability and resource efficiency, and next educational values, that are concept clarity and hand-on learnings, and error-based learning, critical thinking and design sources, and all these are the things. And whereas like some persons they are the things that will be easy for them, and for engineers that is they go under the debuggings. And testing is not about just for the checking process on the full adders. It enhances the usability, learnings and performance of all the things. These things are all about the testing based on the full adder approach.
Okay, at last coming to the final discussion part. The full adder will be basically used in the calculators, the microprocessor, and basically used for arithmetic and logical operations. Okay, thank you students. Thank you for the discussion. Thank you.